Here we have squared plus 12x plus 10 that we need to factorise. We can look at two numbers that multiply to give 10 and hopefully they'll add to give 12. 5 and 2 multiply to give 10. When we add them, we only get 7. When we try and multiply 10 and 1, we do get 10. But when we add them, we only get 11. So we can't use the cross technique to factorise. So we need to try a new technique called completing the square. Now to complete the square, what we do is we write the first two terms. But now what we're going to do, we're going to get the coefficient of x, which in this case is 12. We're going to halve it and square it. But now that we've changed the sum, we need to take it away and then continue. We do that so that the first three terms can always be factorised now to give a nice clean quadratic. Now I'm going to write 12 over 2 as 6, and x plus 6 squared can easily be expanded to give that. The reason why we go ahead and divide by 2 and square it is so that this becomes a perfect square. And I can show you if we were to expand x plus 6 squared, we would get x plus 6, x plus 6, x squared plus 6x plus 6x plus 36, x squared plus 12x plus 36. And 12 over 2 is 6. 6 squared is 36. So we always divide the coefficient of x by 2 and square it, because the first three terms will always give us a perfect square in terms of factors. We then continue the sum, which gives us 12 over 2 is 6. 6 squared is 36. That's minus 36 plus 10 equals x plus 6 squared minus 26. Now that we've got to this stage where we've got a factor squared take away another factor, with the key being subtract, hopefully you'll notice that we now have dots, difference of two squares. And to show you, I can write it like this, which can be factorized, can then be expanded even further, give you x plus 6 take away root 26, x plus 6 minus root 26. And they are the factors